Assalamualaikum, and I hope you guys doing well. For this session, we're going to continue where we left, and this is going to be our last topic for the numerical data analysis. Previously, I have introduced you guys to different type of data analysis. What type of data consists of the characteristic of your data and the dimensionality. And for this particular session, I'm going to discuss the graphical summaries. Let's discuss the numerical summaries. So what's left is the graphical summary. And this is going to be our last topic for the numerical data analysis. So for the graphical summarization, I think you guys well away with this proverb, a picture tells 1,000 words. Ideally, what we want is on a graph, the graph should accurately present the data distribution, how the data being distributed, and also indicate the central value, the mean or the median in your data, as well as the variations that when you take the measurement. The graph should indicate a form of trend or pattern. Ideally, what we want in a graph is the graph should represent accurately the distribution of the data and also provide a numerical summaries. By all means, on the graph, on your data, we could visually see where the central value is, how your data distributed, and also the graph should indicate the trend or pattern. I give you an example. These are the box plot graph. Okay. So the box plot, when we have a rectangular, and then we have at the center, we have the horizontal line, and then we have a whiskers at the top and at the bottom. So what does it mean? It's actually represent the interquartile range. We have the median at the center, the horizontal line here indicate the median. And then at the end of this rectangular box, whether it indicate the first interquartile, the second and the third interquartile. Okay, so we have at the end here, the bottom line indicate the end of the first quarter, the first quartile, and then at the end of the top end of the box indicate the third quarter, the end of the third quarter. The whiskers top and bottom, it's indicate the minimum value and the maximum value. So we have the range from the beginning of the first quarter, second quartile, third, we have the median, the third quartile, and the fourth quartile. So the interquartile range, the Q2 and the Q3 being shown in the form of a box, while the Q1 and the Q4 are being shown in the form of whiskers in the box plot. If you look back at the distribution graph I've shown you before, where we have the center of the distribution is the median, and we divided our data distribution into 4 quarters. If we compare the box plot and this graph here is actually, you rotate this particular graph. We have the minimum values here, and then we have the highest value of your data. So we have the median at the center. We have at the end of our first quarter, the beginning of a second quartile, the third quartile, and the fourth quartile. Okay, so these are the box plot. So if we're looking at here, this is another example of the box plot. What this box plot tells is from the box plot, you know that our data, the distribution of our data. So if I want to draw the distribution, how does it tell is we have the beginning of our data, and then it's increased at the median, the center, and then it reduces. Okay, now we have the distribution of our data. This is our mean, the center, and this here is our interquartile. the end of our first quarter, and this is the end of our third quarter. These are our inter-quarter range, similar to this graph here. So, for another example, these are our data comparison between countries. So what this box plot tell here, this one have a very steep distribution where there is no where the data they are very close together. What does it tell is the distribution of your data is very, very steep. Okay, so it's very difficult to have. So these are your data. Well, this data tells is your graph, the distribution of this particular data for this particular countries. What does it tell here is something like this. All right. So we have a skewed distribution. Okay. Same cases with this one as well. All right. This one have a much steeper distribution and skewed. And this one is equal but smaller. So that's tell from the box plot, we know our distribution. So what these dots tell, these dots indicate the outliers, right? All these dots here, here, and here, all of them is the outliers. So from the box plot, what does it tell? You know from the box plot, it will give you the distribution of your data and also indicate the median, the variance by showing the inter-quarter range. All right, so by all means, from the box plot is also tell the numerical summary of your data. Also indicate which data point is considered or are considered as the outliers. By having this kind of distribution, it shows the pattern of your data across many categories. For example, in this instance, we compare between countries. Now you know the frequencies of your data, for example, in this instance, have different scoring median. So it does show the pattern of your data. The bar plot is quite easy. It's basically showing the frequencies or proportion for any categorical data. For example, we have in this instance, the three categories, the A, the B, category A, category B, and C, and the frequencies. Okay, so whether it's 20 times occurred in the A, or 10 times occurred, 5 times occurs in C. You could present your data, your graph, either vertically or horizontally. The purpose for histogram to visualize shape, center, and variation of your data for which type? For the continuous data, for the continuous type. Okay, so in this instance, when we want to show a continuous data in the form of histogram, the most important bit is you guys need to choose the right bin size. The histogram is actually the combinations of many histogram. All right, being closer to each other. These are the histograms. So now when you arrange them together, now you get a form of distribution. All right. For this very reason, the important things to show the distribution of your data is the size and the number of the bin. So the bin, what does it mean here is, for example, you set up bin is between 1 to 20 values. Okay, for example, in this instance, any values, for example, that have between this range will fall into this particular bin. For example, we have the value 4, 5, 21, 22. Okay, so will fall into this particular bin. Okay, in this instance, we have the numbers, the range between 81, the frequency, the numbers, for example, like 82 occurred twice, and 86, 87. So we have this range, and all these range that fall between this region will be calculated into one bin. For example, then we have this number, we have 5, we have occurred 5 times, 5 in this instance occurred 4 times. Okay, in this instance we set the bin into the range of the size of the bin at 20s and then the number of bin to 5 bins. While in this instance we have the bin size, we increase the bin size instead of taking the range 20. In this instance we have the range we take up to 32 points. So what does it mean here is, So the lowest of your value is 4 in your data set. This is coming from the same data set. Okay. So from the same data set, we know the smallest value is 4, and then we have the 36. Okay. The range, any numbers, your scores, your assessment, your values in your data fall between 4 and 36 will be counted into this particular bin. This is the first bin. Okay, so any values bigger than 36 up until 68 will fall under this bin. While for this one in particular, the 68 and above, so like 69 and above fall into these bins. All right. So what you notice here is the frequency does increase. For example, like this particular bin, so since it's bigger, then it's actually the combination of the values here and the sum of value from this bin. Okay, so this have the 5 bins, while this one have 3 bins, and this one had the bin size here are much more bigger compared to this one. There are 2 types of histogram. We have the frequency like this one, and we have the density histogram. What's the difference between the density and the frequency histogram? The difference here is, guys, looking at the y-axis. These are coming from the same data, all right? Have the same setting, bin size 34, number of bin is 3. So what does it tell here is the density, the maximum value is 1, while the lowest is 0. The difference between frequency is just number, it's just measuring the frequency, how many times that particular numbers occur. So how many times, for example, in this instance, any numbers that range between 2 and 34 will be fall under one bin and occur 8 times. It also depends on the dimension of your data, whether it is univariate, bivariate, or multivariate. If we're dealing with the bivariate data, okay, so by all means, they have 2 categories. If your data both are continuous, then the best way to use both scatter plot or the box plot. If you have a categorical data, for example, the data I've shown you previously, the one with the countries, the data is a categorical, and then the scoring of the particular component is continuous, the best type of graph is the box plot. And if you have both categorical, the best way to choose is the box plot. While for the multivariate data, which is involved more than 2 dimensions, then what you need to do is you need to do some sort of data dimension reduction. But then again, when you reduce the dimension of your data, the critical bit is to make sure that you does not lose any critical information. And the approach that we usually use is a principal component analysis or multivariate analysis. Another approach is we clustered our data into groups, right? And this is approach in the descriptive analysis. The tools that we usually use or approach that we usually take, the method we use, hierarchical analysis clustering, K-cluster analysis, and many, many more. Okay, for example, these are the data for from the PCA, principal component analysis. All the information of your data has been reduced into one single point, into several points, into 2 dimensions. Okay, so what happened here is you have the active oxygen, all your information from several locations. It has been reduced into one single point. So from here, what does it tell is you could tell that we have our data in this instance are being clustered here, and then we have another cluster here, then we have here as well. I'm not going to explain, I'm not going to elaborate for the PCA and the MVA, because these are usually the PCA and MVA usually used in the exploratory data analysis. While for the clustering, you guys clustered your data in this instance, the same data as in this particular graph. In this instance, the approach I'm using is the cluster analysis. Okay, in this instance, I'm using the hierarchical clustering. So we have here is we have the free oxygen percentage, we have the temperature and then we have pH and so on. So we have here is our data can be clustered into two bigger groups, and then further down into another subcluster. All right. In this instance, we have four clusters of our data. So by all means, when they've been clustered together, what does it mean? They have some form of association between the data pretty much close to each other, and they have some form of association. All right. For example, in this instance, for this particular cluster, you guys notice that the temperature is almost similar. Okay, compared to the others. Now, I'm going to show you guys this graph. What do you think type of data or dimension of this particular graph? Is it univariate, bivariate, or multivariate data? Okay, please comment on the section below. I'm going to give you guys a brief explanation. So the horizontal line here indicate the average. The point here indicate the replication or the observation. At this particular one, we have 5 points, and we know the distribution, the pattern of our data, and how close they are to each other. Okay, so what does it tell? What do you guys think? So in summary, a graph tells the readers accurately clear the distribution of the data, and also you should provide somehow indicate the form of data, a form of numerical summary. They show the median, or the mean, and also need to show the variation, all right, and also the relative measures. A graph should have this particular component and is accurate representation of your data. Thank you.